Hey, let's talk about serverless functions. AWS Lambda was launched in 2014 and pioneered the space of completely serverless approach to running the code in the cloud. Since then, every major cloud provider released their own services to run simple, mostly event-based applications without worrying about the servers. Additionally, multiple open-source solutions emerged like Knative, Kubernetes-based platform to deploy and manage serverless workloads. The hero of this video aims to provide a unified way to build, package, and deploy such applications. It's called the Serverless Application Framework, but I will refer to it as simply the Serverless Framework. I will only talk about the open source edition, but keep in mind that there is also a paid service that further simplifies certain operations. Our plan is to deploy a Telegram chatbot that will be capable of translating everything we send to it to the German language. The way it's going to work is the following. When someone writes anything to the chatbot, Telegram will send a webhook to the pre-configured endpoint. The application behind this endpoint will parse the webhook payload and translate the message by using Amazon Translate API. After translating the message, it's going to reply on behalf of the chatbot with the translation, sending it back to the user. By deploying this simple application, we are going to see how the serverless framework works and how much it simplifies and abstracts away for the serverless application developers. Let's start by installing the serverless framework with the simple command. After it's installed, we can create a new service by running serverless create command. There are many templates to bootstrap your service for different provider and programming language combinations. I'm going to use the one for AWS and Ruby. Service in the serverless framework is like a project. It groups together multiple functions and allows you to provide default configuration for all of them. Complete service configuration is defined inside the serverless.yaml file. I'm going to remove the generated one and just write a new one from scratch. First, we need to define the name of the service. Each service has a provider that will run the application. I'm going to use AWS provider here. Inside provider section, I'm defining default options like memory size and runtime, but I can also override each of these options per function. To use the Amazon Translate API, I need to grant certain permissions to the IAM role of the function. For the demonstration purposes, I am going to use the managed translate full access policy, but in production, you should create your policy with a smaller scope. After provider is configured, we can define functions. We have only one with the name translate. For each function, we have to define a handler pointing to the method in the source code that will be invoked. Description is always a nice thing to have as well. We also need to define how this function is going to be triggered via events section. As we need this function to be exposed to the Telegram webhooks, we need HTTP post event. As this is the only function, I will map it to the root path. Final function configuration we should add is environment. I already pre-created the bot itself and saved the token as a SSM secure string parameter. The serverless framework allows fetching parameters from SSM. We are telling it that this parameter is secret by adding true in the end here. Additionally, we need to add a plugin called Serverless Hooks plugin. This plugin allows us to run commands at different stages of serverless CLI execution. Plugins are actually NPM packages and you can easily write your own. Finally, I need to define a hook to install our application dependencies before packaging and deploying the function. Let me copy the source of the application itself. You already saw most of the source before. Now let me quickly install the aforementioned plugin, and we are ready to deploy the application by running serverless deploy command. Notice how little configuration we had to provide to the serverless framework. Till now, our complete source code is just 20 lines of Ruby code and 30 lines of YAML configuration. Deployment is done and we can inspect what Serverless Framework did for us in the AWS console. First, let's head to the CloudFormation. Serverless Framework creates one stack per each environment of the service. As you see, it created almost 1,000 of different resources. If you check S3, then we will find a new bucket just for this service that stores packaged function code together with the compiled CloudFormation template. And of course, it created a new Lambda function hooked to the API Gateway and pre-configured with default logs and metrics integration. Serverless Framework also created a new IAM role with all the required policies in place. Depending on which event sources you use, it will generate policies for CloudWatch, SNS, SQS, and other AWS services. Now let's check the API Gateway. There is a new API just for the service, with a single resource mapped to our function via Lambda proxy. That's a lot of boilerplate configurations that Serverless Framework took care of. Keep in mind that you still need to know what you are doing and which cloud services you are using. For example, it's very convenient to define HTTP events for a function, but behind the curtains we just created a new API gateway with an HTTP API that is mapped to Lambda proxy. That's a lot of moving pieces. Let's try and test our bot. I'm going to write something in Russian and in English to verify that the bot detects the source language. In my opinion, all of this looks pretty amazing. We achieved so much with a minimal effort. There is no need to configure 1,000 of AWS services and bind them together. Serverless Framework hides this complexity from the end user, allowing you to focus on writing the code, and it does it for many different providers. Serverless Framework is a very nice toolchain, but essentially it generates a lot of infrastructure resources. You should make sure that your serverless infrastructure is secure, scalable, and cost-effective. I didn't show many other features like promoting changes between multiple environments. If you want to see advanced usage examples of the Serverless Framework, tell in the comments section below. That's it for this video. If you or your organization needs help or training in adapting the cloud and leveraging the serverless architecture, reach out to us via email in the description below. Don't forget to subscribe to our channel and press the like button. Thanks for watching.